Hello, everyone, and welcome on day 5 of the Swarm Summer School. Today will be a day filled with presentations by our participants of the projects which are currently being built on and around Swarm. I'd like to welcome all guest speakers already joined. We will have a full program today packed with demos from all these exciting projects which are currently culminating on top of Swarm. And for that, I would like to ask every participant if they have any questions regarding these projects. Feel free to raise your hand during the talk or ask your questions in the Q&A section and on Discord in the channel. We have our first speaker, which will be Alok Nerurkar, who is working on the BFS project. Alok, are you here?
Yeah, hey.
Hi.
Can you see me?
Yeah. You're coming through loud and clear.
So, thanks. Yeah, so thanks. I'll just share my screen. Confirm.
Each of these presentations will last maximum 20 minutes, and there's some room for questions afterwards. So, okay, take it away.
Yeah, thanks. Yeah, so hi guys. My project is basically BFS, which is like a backup and recovery solution using Swarm. So I'll just start with like introducing myself. So I'm basically part of the B team. I've been working with B for the past 5 to 6 months. Before that, I have some experience in like the storage and networking industries. I'm located in India, and you can reach out to me on GitHub here. So talking a bit about BFS. So what I wanted to build was basically a backup solution for users to sort of back up their personal data, or you could even extend this to having like a fully deployed solution where you could sort of back up like files, directories, and they'll all be stored in the Swarm network. The additional part that I wanted to provide was having like a snapshot functionality. So if people are aware what is a snapshot, it's like a point of time image of your entire file system. So with snapshots, what you could do is you could pretty much go back in time and pick and choose what version of the files that you want to restore. The other thing would be in a backup solution is definitely you should be able to restore the snapshot and the files. So that's sort of one of the important goals of this. And also provide like a simple management interface. So by management, I mean like, so when I started thinking about this, I modeled this around like the Google Drive folder or the Dropbox folder that we have, right? You just have like a simple folder on your PC. You put stuff into it and sort of syncs it with the cloud from time to time, right? And you can access it from any other machine or give access to other people and things like that. So BFS sort of it wants to be that Google Drive folder, but for the decentralized ecosystem. So why use Swarm's disk? So the main thing in Swarm's disk is content addressing. So as you all know, so basically a piece of data is represented by its hash of the content. So it's always going to be unique, right, based on the content. What this provides is like global deduplication. So a background is like me being from the storage industry. These are sort of some of the buzzwords that you have, right? Like global dedupe and things like that. So like systems that implement this. But essentially with Swarm, we get it out of the box because as long as you're going to store the same chunk, it's going to have the same address. So, it's not going to be stored twice. So it sort of provides you that out of the box. Again, another buzzword would be like incremental snapshot. So what this means is like you keep backing up stuff, right, on your drive. Say things are changing, like you're sort of editing some of the files. So you don't want each snapshot to carry the entire contents of the file system, right? So we want only sort of the changes that are happening as part of snapshots. That way they could be light and they could be easily stored and pushed around the network anyway. So again, this comes out of the box because um, as you change files, like as long as like the chunks are sort of they might get changed here and there, but overall, like if you have same parts of data in the same file, you're pretty much having the same chunks when you back it up. So only the newer chunks, like the newer data that you're adding, will sort of be part of the snapshots. The other thing is, like, as we all know, like the bunch of talks that have happened this past week. So privacy is like a very big concern to, I guess, most of the folks that are part of this. You basically, if you use Google Drive, like you don't really know what is being done to your data, right? So you don't really have access to what they're actually doing. But with Swarm, as we are like open source, you exactly know how your data is being pushed to the network. You can encrypt it and make sure that no one you don't want has access to it. So things like that. So all of these sort of are the reason why I sort of thought of this backup use case could be like a very useful thing for us. And the other thing is the manifest. So as being part of the B team, so I would also like to introduce some concepts that we have in our sort of ecosystem. So a manifest is just like a data structure we use to represent like files and directories with their metadata. And this sort of translates well to having a whole file system built around it. So I'll probably talk about this more later. Yeah, so being like from a backend, I'm a backend engineer, so user interfaces is not really something I pay heed to, I would say. But yeah, so I wanted to be able for like this to provide some advanced functionalities of backup, like all these niceties, but also wanted to make it as simple to the user. And also take some of the concepts that I've learned from my past in this industry, like how to set up like all these backup relationships and things, right? So what I would introduce some concepts here, which is like relationships. So what I want is, say a folder on your machine is in a relationship with some, backup target, which is, and you sort of define policies on it. So you can have like hourly, daily snapshots. So think about it like Apple Time Machine or any other service that does this. So you could even configure like how many snapshots and things you want to keep. So this is sort of what I wanted in the application. So like pretty simple, just set up a relationship, don't worry about it, and you can sort of query information like the snapshots, like the IDs of the snapshot, and you should be able to restore stuff from that. So this could be restored on another machine anywhere in the world. So this is what the Swarm network sort of gives us. Yeah, and so like for me, like the easiest interface for people to deal with it is have like a file system interface. So people know the interface. You have your Finder, you have your Internet Explorer. Basically, everyone is sort of already familiar with the interface. So this is what I wanted to provide, like have like a simple file system interface, which can even integrate to say other services going ahead. So yeah, so what I'm not sure if people are familiar with Fuse, but Fuse, I just want to introduce this because I've used this in the project. So Fuse is like you can think of it like a library which enables you to build user space file systems. So As you see on the right, like it sort of hooks into your like operating system, like kernel space, and sort of allows you to implement some of these file system operations, right? And that way, like users can just look at it like a regular file system. They won't know what is really happening underneath. And so the other thing is there is a lot of support for Fuse in Golang. So there are a bunch of libraries out there with support, like which provide you the functionality. And so Cgo Fuse, I just want to point this library. It's an amazing library. The good thing about this is it has like a lot of platform support. So it sort of supports Windows, which is from a file system area, people will understand the gravity of it. So yeah, and also some of the concepts that I want to introduce are like from the B sort of land. So B has this concept of chunk, which is like the basic unit of data for us. So it's fixed size, and it's basically it has an address which is sort of the hash of it. So it's unique for the content. Then there is manifest, which is sort of a prefix try implementation. So we sort of use this already to store file and directory metadata, right? And the good thing about this is it's optimized for like space saving. So that's one thing that helps here. Then there are like splitters and joiners. So these are again, this is part of the B ecosystem, like how we split files into chunks. All these sort of libraries are open source, so people can sort of come in, play around with this, you know, if you want to build like tightly integrated applications. And then we have like the get and put chunks. So as we know, the B API sort of is a chunk store, right? So you can sort of get and put chunks. So the difference between what the API is with files is and chunks is like you sort of create the format beforehand. So if you know how to create a chunk, you can use the chunk API, you know, to interact with it, and then sort of build other things on in like your logic to sort of, you know, create these things. And also there is this postage batch and stamp. So I'm not sure how many are familiar, but if you played around with it, basically like a way to attach value to chunks. So this is the on-chain component in B. So you sort of buy a batch and then you sort of upload data using that batch, and that's how when people get your data, they know how to prioritize and get rewarded, incentivized on it. Okay, so yeah, I mean this is just a simple, as you can see, very simple diagram. It's just how the project is sort of structured. So there is like a daemon process which sort of provides an HTTP API, right, to interact with. Right now there is a CLI interface, but this could be extended. And then there is a mounter sort of component which can be used to mount multiple Fuse file systems. So what I wanted to do here was you could be able to set up multiple folders, so it should not just be restricted to one. And each mount, as you can see, it's going to run like a process which is going to trigger on the Fuse calls, and then that has sort of access to a local storage, right, and a cron library. So cron library is sort of these policies that you set up, right, to set up snapshot set intervals. So these are sort of cron jobs that will run, and local storage is basically so as this is a backup use case. So I didn't want. So B is not at the place where I think we can do like an active file system on it, because that's why I thought like what we would have sort of a hybrid file system where you could have some sort of local storage, and then a snapshot would be a place where you would push the stuff to the network, right? And this mount sort of provides you the file system interface. So this can be used to integrate with a bunch of different, and then when you basically do a snapshot, like what is happening is it's going to be talking to a B node on its HTTP API, right? Using like the chunks API. And then these chunks are going to be pushed to the swarm network, right? Based on their address, basically. So yeah, it's as simple as I could make it, but we will go through the use case, the demo, and then have more. Yeah, so I'll just move over to the demo. Yeah. So one more thing, I think, is this sort of visible? I think it should be. So one more thing I wanted to introduce was this dev mode that we have now. So it's basically just a small B, node running locally, not connected to the network yet. This is a good tool for people who want to build apps, right? They could see how the APIs function. It's good for testing locally before you get into like blockchain and setting up everything. So, and then what I'll do is I'll start the BFS daemon here, right? And so I have this directory here, BFS, right? It's an empty directory. Now what I'm going to do is I'm going to create a relationship that sort of sets up a backup, relationship. So, okay, before that, I think what we need to do is we need to create a postage batch, right? So again, this is running on the dev node. So this batch is just like a dummy batch right now, right? This can't be used outside of this node. But yeah, so for the function of this demo, I think we have enough stuff here. Yeah, so BFS. So this is the CLI utility. So there's a command to start a daemon, and there's options to like mount, restore, and like take snapshots and things. So I'll go through each of them. So what we'll do first is we just create a mount, right? Yeah, so then what this does is this associates this batch with this mount. So whatever chunks are going to be pushed for this mount point, they're going to be using this batch. This is again this is sort of like you can sort of estimate how much GBs are you sort of looking for and create this batch. And then one more good thing is there is the postage stamp indexing. So the newer chunks will be sort of automatically used. So I mean, it's sort of I don't want to go into too many details, but yeah. And then there is this local store that we have, right? So there are a bunch of them. Actually, there are two of them because it's a simple get put. So I've sort of created a bunch of them. So Badger is pretty fast, so I'll use that for the demo. Right? So okay, so some logs here. So if you can see, like all these are sort of the file system operations that are happening, right? Which are sort of implemented in the daemon, right? And then you have this BFS. So now I can actually go into this BFS, right? And what is happening is as I go in, there are like all these commands are sort of getting executed here, right? I can create a directory, say, let's create B1, and if this is visible, right? And now just create another directory, right? And I'll also create we can also cd into the directory, right? So create a file, say 10 MB, right? And then so you see, Badger is pretty fast, so the writing is pretty. Yeah, so if you see, we created this structure now. We have directories, then in the directories we have files, we have a bunch of metadata here, even the timestamps are there. So all this is sort of the file system metadata. And all of this is sort of going into this Fuse implementation, which is writing things on the local storage. So it's being written in the local storage as you would have it in on a B node, but not actually pushing it, right? So now say, right now what has happened is I haven't set up a policy. So if I see, right, mount, so that I can list the mounts, right? So you get, yeah. If you see the default is daily, so this is sort of going to run every day and create a snapshot, right? And then set a keep count to 5, so it will sort of keep 5 snapshots, so your entire week worth of stuff, right? So this is there by default. You can also change these things, right? And then there's also a way to force creation of a snapshot. So I'll just do that right now, right? So okay, so we've sort of created a snapshot. Just let's look at it now, right? So we have the snapshot. This is the reference. Now what this is basically a manifest, which is which contains the entire file system info. So it has all the metadata stored inside it. And it has also, what it has done is it has created the files, made it into chunks, and also stored the root reference in the manifest. And it sort of backed up the whole manifest to D. So if you see now here, it sort of sent some chunks here, right, on B. This is dev mode, but yeah, and this is sort of the manifest. Like I've just kept it in log so people can see like how this looks. So you have your root, and then you have the directories, and then these entries are basically the swarm addresses, and this is sort of the file system metadata. This is sort of getting pushed to B, right? So okay, big deal. So now what we'll do is we just add another directory, right? So we just create a D3, and then go to D3 and create a file, right? So 10 MB. So, and then you can always like repeat this process, right, and create more snapshots, and then yeah, you can see each snapshot and the synced here, right? So what this does is this will also query the B node and see how many chunks are synced to the network. Right now, as this is running the dev mode, this is just saying that okay, everything is synced, sort of. But yeah, if in this sort of creates state in the B, and like keeps track of the backups, so you can actually see how much of it is synced and things. Right now, okay, so now I have this snapshot, right? What can I do with this? So let me. So okay, one more thing I can show you guys. So there is this file browser. So you can always see this in your Finder, right? So if you see this, right? So this actually comes into your Finder, right? And you can actually even browse this on your machine. So this looks like an exact directory for the system. And then also wanted to show there are like few apps there which you can sort of expose this local disk onto your network, on your machine as a so as HTTP. So you can even provide like access. So this is like open source project file browser. Uh, it can basically show you. You can even upload stuff on it. So you can upload a right. So yeah, you can even see it here. Right. All this is being run on the fuse mount, right? So if I go here now and I'll just stop it right now. Just even this image is still going to be here, right? So this is all going to be there, and then you can always take a snapshot of it and things. Okay, so now what I'll show is the restore functionality. So right, so you should be able to. You have the snapshot, right? So what I can do with it is there is a restore. So there are two options. You can either restore like a single file from a snapshot, right? Say want this particular movie that you had at whatever time, right? Then you deleted it or whatever. So you can always have that one file back, or you could just restore the whole snapshot, right? I'll show is, and then you can also provide a directory for it to restore to, but just go to the defaults. We'll sort of create a tar here, right? And you can even, yeah. So if you see, this is from the first snapshot. So we had only D1 and D2, right? And similarly, we can, yeah, see that all these chunks are getting retrieved from the B node actually. So these are all pushed by your BFS, right? Yeah, so that's, and yeah, we can even see, say, so now we have, we can do this. So I'll just show you the file restore, right? So I have a third file in the second snapshot, so I can just say, okay, wait, this one, right? So yeah, so it just restored this F3 here, right? So all this is again coming from the B node here. So and what it's doing is it's actually just looking up this manifest. So it doesn't really need the whole info beforehand. So this manifest has all the information to look up each file and get that particular reference and pull it back from the network. Yeah, so I think pretty much wraps the demo. I think we can go back to the so some future work, right? So basically, so the backup is not really an ideal use case for B because like the network sort of prefers like popular data, right? So and your backups are not really that popular. You're going to be storing it and not looking at it and things. So the but what I want is like since the disk is going to improve over time, right? Like there might be a time where we could actually just have this as like an active file system, right? We just and we can even use like other features that we have in B to sort of communicate like new stuff being written to other places where it's mounted and sort of update them and things, right? So all this is possible once things improve. Right now, I still like that. There is like use cases for it. Like people can always use it as a backup. If they even want to share files or things with others, they can use it. And I would love some feedback also. And we also thinking of integrating it with FairOS. So I'm not sure if you how familiar you guys. I think there was a FairDrive presentation the day before. So so there are things that are being planned here as well. Also, I'm looking for more people to get involved. Like this is a good place to start. Learning about different concepts around B. So like although we want it to be transparent to people, but it's always good for people to know stuff and even make improvements if need be. So and yeah, one more thing is I was thinking of we can sort of use this as a Docker registry for like having your registries on Swarm, right? Because like you can have a Docker local registry over a file system, right? And that could be this BFS, which is backing up to Swarm network. So this is also something I plan to try out. So let's see how this things go. Okay.
Thank you very much.
I think yeah. So
we have some questions coming in. I'm going to repeat them. One is from the Q&A section from iDefnB. He's asked, first of all, he likes where you're going and he will check out your GitHub repository. But he's wondering, have you done any testing with large collections via the B manifest? And he gives an example about a collection of 22 gigabytes. And he says, yeah, large files don't seem to be the issue, but large file count could be a problem.
Yes. That's true. Like, yeah, there are like limitations with the manifest, definitely. But yeah, these are the things that we want to improve, right? So if we have some need for it, I think people are going to step up and improve things, right? I haven't personally tested these large collections because this was more of a side project I was working on, but I think how the ecosystem is developing, I think this is sort of important to get out there and like have more people work on it. And I do see like these numbers like will cause issues, right? So because right now I think the manifest it's entirely in RAM, as you said. So yeah, but it's more of opening up to people. I'd love it if people can come and solve these problems as well. Yeah. Yep. Okay.
Wonderful. I really like the functionality. I like the Apple time machine function as you described it, and it looks like it's has the ease of use of being combined with like a feature like Mega used to have, but then open source and distributed. What more is there to like? Yeah. Yeah. Okay. Thank you for your presentation. And if there are no further questions, I'd like to invite our next speaker, which would be Dimitri Palchun, who's working on the Daplets project. And one of the projects within the Daplets project is the Swarm Search project, which he will demo. Dimitri, are you here? Are you online?
Yes, I'm here. Should I? Oops.
Yep.
Yes. I would like to switch off my video and share the screen. Is it okay?
Sure, go ahead.
Do you see my screen? Can you hear me?
Yep, coming through loud and clear, and the screen looks good.
Okay, screen is good as well. So I would like to present you our project, Daplets project, and some kind of sub-project we have implemented inside of it as a Swarm Search. So, what is our mission and what we are doing as a Daplets project? We are building an augmentation web or the augmented web, and our mission is to provide you with a tool set to shape your own information ecosystem. And with our project, with our doublet, we can also enable fundamentally new workflows and popular websites. And essentially, we provide Web3 technologies for legacy web. So essentially, we are decentralizing UX. We are decentralizing the web on the UX level. So how it works in general. So if you have some web layer, as you know it, so you see the dog on the lowest layer, we put some kind of adapter on the top of it. This adapter defines visual elements, and also this adapter makes some kind of parsing of visual content, website content, and pass into some kind of semantic Web3.
Dimitri,
Yes.
we have some question that there's some background noise where you are. Could that be the case?
Maybe so. I can change my location because I'm on the road. Let's say change my location. We will see if it will better.
This is better. Yeah, much better.
Okay, it's not yet. Okay, we'll see. So then the doublet is an application on the top of it. Use this visual augments like mustaches. And then what you see, what you become in the augmented dog and augmented content. So why do we need Swarm? Because our platform is meant to be decentralized and unstoppable, and we do things that probably not everyone will like. We need to be decentralized and unstoppable, and we need to store our modules, our applications in this way, and decentralized and unstoppable, and that's why we need Swarm to make it. Yes, and that's why we use Swarm to store our data. But not only we need Swarm, also we hope that we can create a huge added value for the Swarm. And that's why we have introduced Swarm Search. Well, Swarm Search is an opportunity to inject the results of search in Swarm network. We inject this results of the search results into the website where the user makes his search. For example, this is YouTube. So, and then, for example, if you make a search, we can start our application. We can create, we switch on Swarm Search, and then our plugin, our doublet, injects the results of search in the Swarm from the Swarm into the YouTube, so that the user who performed the search on the YouTube will see not only YouTube videos, but the content which is usually stored, which is stored on Swarm as well. So this is how it works. But how we can find these videos? Essentially, we need to index these videos we index metadata to these videos, and we have augmented Swarm gateway. Yes, we have just augmented Swarm gateway to collect metadata and to index it. So we can just see how it works. So this is usual Swarm gateway, but there is a doublet running on the top of it that goes inside the Swarm gateway and collects metadata from the user about the file he uploads. Now you see this doublet Swarm indexer running on the top of gateway, and this is how doublets gets injected or other copy rates gets embedded into the swarm gateway. We collect metadata from the user, which is currently not the functionality of the swarm gateway, but we need it. So that's why we have extended the functionality of swarm gateway in this way. And this is essentially the way how we extend the functionality of any website. So then we have uploaded this metadata. And then if we make a search on Google search, then we can see that some Google search results were augmented with Swarm search. So essentially, we have injected on the fly the results of the Swarm search into the Google search. That's just how it works essentially. So, you see this icon on the top of Google search means it's not the native Google search results, but it's injected on the fly from the Swarm. So how it works, what the architecture of the Swarm search? The uploader uploads his file and inclusive metadata into the Swarm gateway. And then we have an indexed doublets that collects the metadata and pushed into over the search API, and it's stored into the Elasticsearch engine. And then after the Elasticsearch engine indexed this metadata, it is possible to make a query and get results from this index. And based on this index, we can get results from the search and inject them into the YouTube. So this is what the searcher do. You can see that this Elasticsearch is not really decentralized. It's some kind of mock, and we hope we will be able to implement a truly decentralized search on the top of Swarm, and this will be the next step. So Elasticsearch is a mock, and we will change it. Well, we hope to change it together with the Swarm team. Another interesting part is the search API, and there is this open standard, open search standard, and we suggest the Swarm team to implement OpenSearch API on the top of the Swarm. And once it's get done, it becomes possible to, for any website, for any browser user, to define Swarm search as the standard search engine in the website, in the web browser, like Google. It's not about doublet functionality anymore, but it's just something that I suppose will be very useful for the Swarm adoption. So once more about components in the Swarm search architecture. There is an index of doublets that collect metadata and send it to the indexer. The search doublet essentially makes requests to the backend, injects search results into third-party websites like YouTube. And search API is essentially currently an open search API. And the server implementing it transforms the search to the request to the backend and make essentially a search. The Elasticsearch is an indexer, and it's a centralized mock currently. We need to replace it with a decentralized implementation on the top of Swarm. And yes, We have augmented swarm gateway to collect the metadata, but in a very similar way, we can augment any upload website. So we can just intercept any upload and collect metadata and the file from the website. Yes, and nodes essentially. That's our gateway to the swarm network. So that is, if you share our values, let's talk about cooperation. And feel free to visit and subscribe to our news. And let's talk about how we can decentralize the vault on the visual layer. And this is that we are currently doing. So that is. Thank you.
Thank you, Dimitri. What are you currently looking for? You're looking for additional developers on this project or projects to integrate it?
If I understood you correctly, I asking about what we are looking for.
Yeah.
So,
yeah.
In this project, in the Swarm Search project,
yeah.
We are looking for support. How we can implement the indexer on the top of Swarm in decentralized way, because currently it's a mock server. No, it's full functionally so, but it's centralized. It's just one server running Elasticsearch. It's not really what we would like to do. Just a test of, it's a test essentially. But we believe that it's possible to implement this functionality on the top of Swarm. But the question, who would help us to do it?
And then another question we got was, which browsers do you support?
Which browsers? So currently we test it in our plugin. We test it in Chrome, but essentially it's was developed to run in major browsers, in Firefox as well. It should run in Opera, but okay. To be honest, we don't test it every day. Maybe it's got broken because we not released it yet. That's what we are doing.
Okay.
But yes.
And perhaps redundant, but if people want their files not to be indexed, they shouldn't use the Swarm gateway in that case.
Sorry?
If people would prefer their files not to be indexed by the application, by Swarm Search, then you advise them not to use the Swarm gateway.
Okay, we need to collect metadata in some way. So if it could be Swarm Search, it could be a Swarm gateway, what we intercept, but it could be any other website that we which upload we can intercept. We just create an interceptor to show how it works. We have created an applet intercepting Swarm gateway uploads just to show that how we think about websites. We don't ask to the website owner. We do just create a applet and in some sense break into the functionality and extend it. So this is what we did with Swarm Search. We have just extended Swarm gateway functionality to collect the metadata.
Thank you. It's intriguing because imagine it could be hooked up eventually to other decentralized networks as well, perhaps, to form one overarching search. We got a question from Victor. Does the gateway augmentation inject a form to the page and send its form data directly to the indexer?
I'm sorry, I can't hear you clearly. Could you repeat it? Sorry.
Let me repeat that. Does the gateway augmentation injects a form to the page and send its form data directly to the indexer? Is the question.
It's yes. This indexer currently is the server, and yes, the doublet collects the metadata and send it to indexer, and indexer make it possible to map the results of the search to the swarm cache. Have I answered the question?
Yes. Okay. There are no further questions. Thank you for your presentation. And, good luck with the project. I would like to invite Tadej Fius, if he is available. Hey, are you live?
Yes, I'm here.
Hi. To present the Energon X project, which is currently being built on Swarm. Today, do you have a presentation or a video you'd like to share?
Let me share my screen. Okay. See it?
Yeah. No,
So
looks good.
So what we are trying to do is build a marketplace for hydrogen producers and hydrogen service providers, and of course consumers, so they can offer and find the green hydrogen, mostly green hydrogen, on the market. So we believe that the big energy transition is coming, and it's already actually happening. And we believe that in near future, the energy market will change drastically because of the hydrogen and how the hydrogen is actually can be produced. So these are the fields where hydrogen can be used, is already used, or will be used. Some of these fields will actually be profitable. Some will be profitable because of the CO2 reduction of emissions, and some will be non-profitable, right? For some, we already know which will work good. For some, there's still a lot of research needed to be done. But basically, as you can see, it goes and it will influence majority, if not all, of the energy markets that are now dominated by oil and gas industry. So where are we now? We are a startup. We are trying to solve discoverability of the green hydrogen. We use Swarm for immutable storage of, so we track everything, right? And we publish all the cancellation statements on Swarm. We are looking for funding, of course, and looking for partners, namely the liquidity providers, the hydrogen producers, of course, the consumers, and other service providers from the hydrogen field. And of course, we are looking for the developers to help us build the product and expand it even more. What are the challenges? So the challenges, the market is mostly wholesale limited, which means that the power purchase agreements are mostly done for longer periods of time and for fixed cost and price. And it's very difficult for small producers to enter the market, or for small consumers to buy small quantities of this commodity. We want to establish access to large-scale producers, so you can, as a small user, you can get small quantities, and if you're a small producer, that you can deliver your product into local storages for a normal or competitive price. what we also aim to is to reduce the high operational costs, because right now, if you build like a big hydrogen and plant, production plant, it requires quite a lot of legal expenses and other costs for stakeholders, and we aim to reduce this part of the operational costs. And of course, we want to change how the energy market is working, because we don't want that the same thing is happening as is happening in oil and gas industry, where the speculation and the manipulation of the market influences, let's say, whole civilization. The market is huge. These are the estimates from the European Investment Bank. What we are building now and what we are working on is a location-aware trading platform, marketplace for the hydrogen. We also have the other different products that can be like a side product from the electrolysis or the pyrolysis or recuperation or something. It's very inclusive. You don't have to pay a lot of money to get in. Basically, there's just like a need for the verification of the parties that are on the platform, and that's it. So there is there are no fees connected with the if you want to use the market, because, for example, if you want to do electricity exchange, or if you want to do the gas buying directly from the producer, you need to pay like huge fees for just to be part of the network. We promote regional connectivity and locality of the users, and it's completely transparent and traceable, and there's like no middleman in between. We connect consumers and producers, and of course distributors, and as I said, we reduce operational costs, and this will makes the hydrogen much more accessible. So we still have quite some problems regarding legal framework and the guarantees of origin and all this stuff. Still waiting for some from the EU Commission, what will happen on that part and how the certificates will go and all this stuff. We did something on our own, but still we will have to wait for this to become the part of the agencies for the energy from each state that will be part of this energy transition. It's for now, it's unique. We didn't saw any other solution like this that's so inclusive and to be like a market enabler that enables also other like smaller parties to be part of this energy transition. So where it can be used and how the value chain goes. So the gray hydrogen is where you produce a lot of CO2, right? And the blue hydrogen is, so the majority of the hydrogen right now is actually blue hydrogen. It's like, so the hydrogen is like a byproduct from some chemical reaction or something, right? And then you have like a green hydrogen, which is completely renewable. It comes from either wind or photovoltaics or some other renewable power source. So how the rollout is happening. So immediate next steps, now it's going into the transportation and then the light duty passenger vehicles, and of course distributed power and green balancing, and all this is already happening, and diversification until 2030 and 2030 and beyond. It's very ambitious, but the hydrogen will be mostly, or let's say, inclusive in the industrial world and the mobility and transportation world and heating, and of course green balancing. So the market, as I said, is huge. We are not in it only for the market, but we really believe that if we do a system that can trace everything from the renewable energy source to the supplier, the power for the electrolyzer and tracking the production of the electrolyzers, and then storing and calculating all the capex for the storage, and then of course the distribution and refueling or consumption, we can say consumption of the hydrogen. If we can track all these, then we can do lots of other stuff like analytics and of course prediction markets and stuff like that. So where are we now? So we have like orders, we have auctions, we have distribution, and we have tracking of the distribution of the packages and stuff. It's a hybrid centralized architecture. We use Ethereum for value transfer. We use Swarm to store immutable data. And of course, everything is ready for tokenization. Why Swarm? Because we know exactly who can write and who wrote something into it, and the immutable records in this, let's say, industry segment is very important, and with this you get this trustworthiness that's otherwise quite difficult to reassure, your clients that your records are truly immutable. Because we are location aware, we can do like transport route optimizations. We have some APIs ready, some are still in the works for third-party integrations, especially on the part of logistics and statistics and analytics and all this stuff. It reduces like a lot of risk management, and of course it increases the usage to the consumer. So our vision and plans. So we are mostly ready with the marketplace, except the capex calculation for the storage. This is one of the things we plan to roll out the first phase of the marketplace in 2023, the start of it, and the fully functional location-aware trading in 2026. So at that time, we will have the whole chain from smart metering of the electricity production to the automatic trade execution, to the calculation of all the storage costs, the transmission, the settlement, the insurance, the reporting, all the parts of the order and tracking inside. We will have the option to deploy like a local autonomous marketplace that is not connected to the global part, to the global network. So there will be like countless small little autonomous marketplaces. So basically tracking from the production to the consumption with the automated billing and micropayments, of course, the market intelligence on top of it, and service providers, and of course, third-party integrations. So right now we are working and trying to find hydrogen production facilities. From some, we already got the interest that they are interested to offer the hydrogen on our platform. We are looking for equipment companies, and we also have some partnerships with them also. And of course, the distribution companies and the companies and the partners that drive adoption of green hydrogen. We plan to incentivize the local production of the green hydrogen. This will require being compliant with the financial laws, but this is also something that we are looking for, because the end game is actually the commodity exchange for the hydrogen, green hydrogen. And then by the end of 2030, when the broad rollout of the hydrogen will be available, we are hoping and targeting that the marketplace will become completely trustless and autonomous and decentralized. So from that point on, we just tackle and do the data management on top of it, because there's like enormous amounts of data that happens from this from all those deals, and working on prediction markets, and of course trying to solve the combinatorial problems when you start to do orders, when you have like multiple sources and multiple destinations, and the complexity of these combinatorial problems just explodes. So after the decentralized system is established, this is where we will focus our energy on. Okay, so the revenue streams are coming from the marketplace, something from withdrawals. Right now we have crypto only, but we need to build the euro-denominated market for the hydrogen. We are selling the transportation information, so the distribution companies actually auction for the distribution, and we have like a hydrogen index. We can have like a global hydrogen index, and we have like a local hydrogen index from the different, like I said, autonomous marketplaces. Of course, we have some of the market analysis. This is also like data as a service being sold. We charge for the notification systems and of course for the procurement network. So in the future, what we are looking for is also the income from the validation services, you know, from so you know that the manufacturing equipment is being built by trustworthy, so not the trustworthy, by the trusted parties, and they validate all the equipment, and they vouch for it, so the reputation is also being included in the system. And then, of course, the issue of the certificates and tracking of the certificates, and of course, become the exchange with term contracts and, of course, for futures trading. So these are, let's say, future goals. Yeah. What we see with this is, of course, a lot of growth and, of course, of jobs. Most importantly, reduction of the CO2, so something for the future of our next generation and the generation after them. We believe that the climate neutrality, for this to be achieved, we have to play part of it. We all have to play part of it, and of course, we think that this will bring broader social and environmental and economic change, you know, and of course, with the adoption of the clean energy, we believe that the world will be a better place. So what are we now? Where are we now? We are part of European Clean Hydrogen Alliance. We received a swarm grant. We have some interest from equipment manufacturers and, of course, the hydrogen producers, and we have operational prototype. So I will do the demo now. If you have any questions, we can do this. So this is the parties involved, the team. Okay. So just log in. So maybe I'll start this. So who are the users? As I said, the producers of the hydrogen, the distributors, the consumer, the buyer, and then the analytics guys that take the data from the platform and do the analytics and sell it back to the users, and then only the providers of the data that can provide the data. And the procurement network is, imagine like Amazon for equipment manufacturers or the buyers that already have established like electrolyzers or production equipment or something like that. So yeah, so we have like a marketplace. You have different hydrogen. So we have green, blue, gray, white, turquoise. So all these depends how much CO2 you have as a side product or how the process goes. We also added ammonia, which is much easier to be transported. And then we added oxygen because after analysis, we found out that there's like a lot of oxygen that can be used, and of course salt and carbon. Carbon is a byproduct. If you do the pyrolysis for the hydrogen, there's a lot of carbon that can be used as also again as a fertilizer or producing nanotubes and stuff like that. So there are different like qualities of the hydrogen, for example, green, gaseous, and then the quality is 99.999%, and then we have like a liquid hydrogen again with different qualities. So this is the it's like a double auction system with a little bit of the turnaround trick is so everything is geolocated, so you know who's the closest one to whom. And you can publish like a spot price, and the buyer will buy the closest one or the most appropriate one. Then we have like an auctions when the producers can just say, okay, I'm willing to sell 2,000 kilograms in the next 10 hours. And then they create the auction, and then the other customers can bid for it. So the difference between the auction and the marketplace is that you can only buy the whole lot. And then, of course, we have the distribution where distributors bid for the distribution and then after deliver it. So in the background, it's actually like it's like you make escrow accounts, so the distributor until it delivers. He actually owns this batch or the lot that needs to be delivered. Right. So the usability of this delivery of the hydrogen is up to 450, 400, maybe 500 kilometers. Right. So that's a local distribution and not like long term for those the pipelines will be used. So we have like vendors. Okay, so I bought some before. And I will show you. So the difference between the commodity exchange and the marketplace, what we are doing is you actually know from whom you bought. So there is no like middleman in the between. You actually bought this from the party, and you know from which party you bought this, right? So what we are storing on the swarm is actually this information along with cancellation statement. So we know which transaction, which certificate from which certificate to which certificate this was executed, and all this stuff is then stored on Swarm. And it's like this. You can think of it as a recipe, or it's a cancellation statement. Yeah, but you know from where the energy came, what was the device that produced this, and from whom you bought. And of course, all the details of the order that you did. So we also have some of the statistics. We have like an index, and then you can see the market, and you know exactly who bought something from the country, or deals per country, or prices per country, and all this kind of stuff that you can calculate because we have like a geolocated market. So yeah, I think that this concludes my short demo and presentation. If you have any questions.
Thank you, Tadej. I love how this is a project which has a real world impact and has built its premise on top of this new infrastructure. Let's see. I was wondering, you mentioned the aspects like location-aware trading. How are you solving the Oracle problems? Do you have you work with sensors on these shipments?
So the centralized part is so what it does. So the majority of the centralized part is, so we have one thing called like multi-transport protocol layer inside. And this protocol layer is actually a thing that you can embed into, like, for example, into the nozzle or into the electrolyzer, right? So the user interface that I showed you, this is actually, in 10 years time, it won't be used because the machines will do all the trading. So if imagine having like a nozzle at the refueling station, and the refueling station is running low on the hydrogen, and the machine says, oh, I'm running low, and it just goes on the marketplace and says, deliver me 300 kilos, and the trade is executed, and the truck is loaded, and the truck delivers these 300 kilos to the refueling station, and that's it. And the same way it goes from the nozzle and or electrolyzer, right? So you know, that's why the analytics part is so important, because if you do proper analytics, like, you know, the prediction markets, and you know the weather is good, and I have like a photovoltaics electrical source, and my weather today is bad, so maybe I will just buy the hydrogen, or my weather today is good and the neighbor's weather is bad or whatever, so I can produce, I should produce more and not sell the electricity directly to the grid, but I should produce the hydrogen, right? And all this stuff will influence and basically be done completely automatic by the machines, right? So the electrolyzers will say, aha, I don't need to produce because it's better if I don't produce, or I have enough, or I have not enough, you know, and all this you know, the equilibrium will be always be trying to reach, right? And the marketplace just like enables all this stuff to do analytics and predictions on top of this, and especially if it's like a global, or let's say like a wider range, then you can do a lot of the optimizations regarding the production, or you are sending into grid and stuff like that. So yeah.
Let's see. We have a question from True. Let's see. Oh, first one from Tomasz. Will your marketplace add any other additional energy products in the future, perhaps related to hydrogen?
Well, the energy product, you mean like the electricity? Because, you know, the hydrogen is actually not the energy product. It's like a compound chemical compound, you know, it's like a vector for the energy. It's a compound that you need to change, and then you get the electricity out, right? So you need
a building block
cells and stuff like that. So not directly the energy like electricity. No, we won't do that. But as I said, as I shown, the parts or the different compounds that are connected with the hydrogen production or transmission, those we will include, and we already have, like I said, carbon and oxygen, and this is like a quite a big part of it, right? And very useful. The carbon, the black carbon, is useful in a lot of parts, and it has its value, right?
The question from Chert was, will hydrogen be the fuel of the future for vehicles or electricity?
Well, I think there will be electric cars, right? And the range of them will be, you know, to go for the shop or something like that. The heavy duty vehicles and trains, where you don't have like electricity, the trains will go on the hydrogen if you don't have the electricity grid. The long vehicles, you know, it's not useful to have 4 tons of batteries and your vehicle is 20 tons, right? So that will be taken by the hydrogen also. And so I think that also like light trucks up to range of 500 kilometers will also be on the hydrogen. Yeah, but there will be like cars, like personal cars with electricity. Yeah.
And another question was, you now have the data of the movement, which you track and place on Swarm. will you in the future also place potential other data like analytics on Swarm?
So the part that we are developing now is like some kind of a data place where you can ask for this data from the marketplace and get it out. And yeah, that's the idea that goes onto the Swarm too, but we are not there yet. Yeah, but all the daily data, the indexes data and assessments data, they will have to be stored somewhere. So we are targeting for the Swarm. Yeah.
Can the geo data be linked to OpenStreetMaps to be part of a global geo database?
Well, right now we use only like a vector data, and we only have like support for EU, and the optimization, route of optimization, we are using third-party solutions for it. Probably in the future, somebody will come and say, "Ooh, look, we have the better or cheaper or whatever," and they will integrate their part into it. Yeah.
Okay. About the project, what stage would you say the project's in right now? Just
So yeah, so we have the working prototype. We are trying to find a solution regarding legal frameworks because it's still quite difficult, So every country in EU has different regulatory requirements for the transportation of the hydrogen, for the production of the hydrogen, for the usage of the hydrogen. So this is something we are waiting for. But our plan is to roll out the marketplace with the discovery for the hydrogen and especially the green hydrogen in 2023 at the start of it. So this will be without the distribution part, without the auctions for the distribution. This is it will be like so the buyer has to arrange the delivery of the hydrogen. Yeah.
I noticed you mentioned you were looking for funding. Did you apply for EU funding?
Oh yeah. So we are in the process for the EIC.
Okay. My final question would be, I know you're, and as you mentioned, you are a part of the Swarm grant wave. You received a grant from Swarm earlier on. How has this helped you during your development? How has Swarm been helpful in this development of your project?
Well, it helped a lot. It helped a lot. We had some problems regarding the documentation and all this stuff, but majority very good results, very good communication. Whatever I needed, I got the answers immediately. So all good. I would advise everybody that are trying to work on Swarm and use the Swarm to apply for a grant. And that's something I think that the community is good. The people are great, and I would advise everybody. And yeah, the more people work on Swarm, the better for the ecosystem.
Thank you. I have nothing to add to that.
Okay.
I would, thanks again. I would like to ask our next presenter to appear. Let's see, Petra Wilson. Petra, are you live?
Hey.
Hi.
I got to figure out how to share my screen here just really quick. I'm not sure. Let's see.
Okay.
Virtual.
I have in my notes you'll be talking about interoperable standards for data process flows.
Yeah, so what I want to talk about actually is kind of math. Yeah, so it really starts out with this concept of the minimal case. And so we have different kinds of schema, kinds of relationships. You can have just a simple linear relationship, a scale, if you will. And that's a one-dimensional system.
Is there a name for this project, by the way? Could you describe it?
This is the fundamental basis for the interoperable schema that I'm developing and the interoperable contracts that I'm developing for MicroSpark Fate, which is a media distribution platform.
Thank you.
Okay. So there's lots of different ways to categorize data, and we have data itself and then relationships between data. And these are arranged as nodes in most information systems and edges between the nodes. But there's this concept in mathematics called the dual in graph theory. And in graph theory, the dual of a node is its edge, or is an edge in a graph, right? So for example, if we had a set of just these 2 points, then we could construct 2 edges and connect them, and that would form a dual. So a little bit of this is, I'm gonna try and move as quickly as possible through a lot of math and just kind of point out the relationships that we're looking for. The idea is here that these are the minimal subset structures within a structure that has these numbers of degrees of freedom, okay, within the information set. And so we find subschemas that can be used as the minimal element to produce a schema that has 3 dimensions. For example, you need 1 point and a triangle. As a repetition of those shapes will get you to the minimal shape in 3 dimensions, the minimal polyhedron in 3 dimensions, which is a tetrahedron. And in 4 dimensions, we come across a new shape, this octahedron, the regular octahedron. When we put all of these shapes together, we get something called a tesseract. This is also the projection of orthogonal relationships between entities in a graph. And so the tesseract in 4 dimensions is like a cube. It is the minimal set of unitary relationships of orthogonality within the grid that covers every point in a 4-dimensional space or a 4-dimensional graph, which is not the same as a space per se. Anyway, when we combine all of those things together, it forms the tesseract. And the tesseract is interesting because it also demonstrates some of these qualities of Pascal's triangle, where each node can be represented as a specific binary within the binary Pascal's triangle, and the sums of those binaries actually create the logical operators that we know and love from coding. And we can actually apply those not just on binary sets, but on any base. In fact, when we do it with hexadecimal bases, it resolves to the actual colors. And these colors follow the same color theory, where white is red minus green and blue, or where black is the sum of cayenne, yellow, and magenta. And these actually work out mathematically the same way. So when we're building structured data that's based off of a hexadecimal pattern, we can bifurcate those decimals using an operator called XOR, which is this operation here, in order to bifurcate those streams into shapes that will conform to this shape. And of course, we can do this in higher dimensions. I'm focusing on 4 dimensions because this is the relationships, the nature of the relationships in most data models that we have in the world today. So in the world today, most data models are based off of a user, sort of the source, and a data sink where that data is sent. Or I'm sorry, I think it's the other way around. The user being the sink, the data coming from the system being the source. But within that system, we can split it up. There is a process that occurs over time, and storage, which is an embedding of the data in some kind of medium, spatial relationships. The interplay of these spatial relationships over time actually form the interoperators. So this is spatial relationships. These are temporal relationships within the schema. This is the user. This is the system source. This is the sink. And these interrelationships actually form logical operators that we can perform directly off hash. And we can integrate over those hashes and define a volume within this space. So it's a visual way of representing sums of schema integrated over this minimal case of schema for a 4-entity, 4-relationship, 4 entities, 4 relationships. When we decompose the hypersphere, or I'm sorry, not the hypercube, the tesseract, it's actually composed, again, as I was saying, of these tetrahedrons. And so actually the minimal subset of the minimal schema in 4 dimensions is the tetrahedron from 3 dimensions. And so the idea is to construct a schema that will follow a tetrahedral pattern, and that this would be the minimal case for interoperability between cells in a schema, sub-schemas within a larger schema, to allow us to do this integration fractally, right? So that we can cover the plane and fit the most information into the smallest amount of bits. This is the idea. And so when we do that, we have these 4 basic arrays, which are all tied to the inner array in the dual. And I just combine those into this arrangement here. And so this is just any color directed acrylic graph and the position in it, and defines the context of the document. This is a DID, and a DID is just an address. And we have versions of the same DID. This defines the volume of the space in the center of the tetrahedron. There's a time relation, and the actual data itself, the content contained inside of the object that is being stored within the minimal schema. And then there are the relationships, some citation or dependency of the code that's contained in the hash, and the authorizers or signers of that code or information or data. And then in addition to the idea of differentiation, there's the idea of composition. And so anywhere where this information is cited as a part or another composite contains, so this is a contains relationship, and or is contained by, and this is a contains in relationship. And those are the minimal sets of relationships that we'll need in order to compose subsets of text, supersets of text, but maintain the relationships between the text and the origination, the user source of those texts, and the agreements that bring together the combination of those texts for representation and transmission. Again, this is all based off of some research that I worked with Michael Zargham, and he's a professor out of MIT. He wrote a paper with Michael Stevenson, color-directed acyclic graphs for multi-class attribution networks. This all has to do with, again, these concepts of fractal integrations, and the idea that we want to be able to create quasi-crystals. And the reason for that is because we want to fit the minimum, the largest amount of information in the minimum set of bits, but we also need a architecture that is going to maintain enough symmetry to be parsable over the maximal number of cases. And so actually these tetrahedrons add up across, this is a E8 symmetry group. And if we cross the E8 with itself, we get essentially the bagua, if anyone knows what that is. And these problems are all based on, again, just the idea of close packing of spheres in a space. It's exactly the same problem, right? And because of the nature of numbers bound in the Pascal's triangle, there's a predictable pattern by which we can index these relationships. And when we lay out these cells in sequence, in series, they tile the plane. And so this is very pretty as well, especially if you consider that each one of these classes, these are classes, right? A refined class. And as long as we have a minimal set of classes that will fit within this geometry, then we know we have the minimal set of relationships necessary to relate the system that has 4 entities and 4 processes. Yeah, so this is an approach, right, to developing schema. And again, this is a generalized information theory. So in fact, it doesn't have to apply, for example, to a media source or media storage or media processing or the entities that produce those things or the media itself, but could be applied to any number of different processes or entities. And the process that's being developed here is done across 4, and I'm going to do this for a lot of different reasons. These quasi-crystals in 4 dimensions are becoming incredibly useful in a lot of different applications across industry. This has to do with protein folding, for example, or autonomous control of multiple devices across a grid network. So if you want those drones that fly around in patterns in space, you know, and they're all adjusting to the same wind currents and simultaneously sort of thing, the way that you manage that, again, is with these sort of fractal distribution grids in the nodes, and they play out in these patterns. But you can actually go beyond 4 dimensions into 5 and 6 and on, all the way up to the quasi-crystalline spin network. It turns out that with this level of resolution, right, because every dimension adds an additional degree of freedom and therefore increases the resolution capable of being stored within the schema, right? So at this level of resolution, we can model quantum chromodynamics, and this will be the method for construction of quantum nodes for quantum computers that are stable because they evolve and form these quasi-crystalline structures. So it's not just an approach that will work at 4096 kb in a 4-dimensional system, but for video resolutions in color combinations, 6-digit hexadecimal parsed digits, right? But actually can be expanded the same way to derive these kinds of quasi-crystals to the maximum resolution we need in our universe, in fact. Anyway, that's pretty much the extent of the presentation of the ideas here that I'm exploring and or have been exploring for the last 20 years, and that I'm now building into these schemas for representation. I would think a user interface that works in 4 dimensions is something that we really need to establish because we are using 4-dimensional information systems at this point. Most AI, ML, and other systems are running off of these kinds of degrees of freedom models. Yeah. Yep. So that's the idea of future applications of this.
Thank you, Petra. Very very insightful. Let's see, check if we have recommendations or questions. Here we are. I wonder if we have participants who could respond in this way. We do have a question from again from eDefNB. I confess that I'm not this theoretical, but is there any application of this to resolving version feeds in the swarm?
So actually, eDefNB, you had mentioned in your comment on, I think it's Develop Swarm channel in the Discord, that you were trying to set it up so that you could go back and insert records into feeds. I think this is kind of the problem, right, that we run into. And the idea is a way to create schema that will resolve a way to insert and keep the schema intact, I guess. And in order to do that, it's necessary to classify. But once you have the sequences that are produced out of these symmetries are predictable. They're algorithmic, right? So one could theoretically reserve a sufficient space for the depth of resolution that needed to be formed within an unknown set of variables, and then that would leave enough space to fill in. But there's a requirement here that you have to define the bound, because when you're dealing with non-abelian groups, discrete groups, they have to be finite. Unfortunately, otherwise you resolve to there's a paradox of ambiguity is the term. If we go back to Pascal's triangle and the binary development of it, then yeah, within the binary of Pascal's triangle, let's see, we set up the grid. We have, oh yeah. As we sum off of each row, we end up with the Fibonacci series, and this is like an infinite series, but it's predictable. So if we know the depth that we want to arrive at, then we can cut it off at a certain point and build a geometry out of that. But if we don't know the depth, then it's just an infinite series, right? And eventually it resolves to ambiguity, because in the construction here, when we add the set containing the empty set, there's two ways that we can differentiate the dual. But when we decompose the set containing the empty set, we always get the set containing the empty set. We don't get the empty set. And this ambiguity paradox is part of the basics of whether a problem can be considered NP complete or hard, or whether or not it's trivial. So there are some fundamental limits in computing that require us to have a defined finite set. But once we define that finite set, then if we know our resolution, then we can define that minimal case. And in this case, in Swarm, we have 4,096 bytes, right? Which is a finite number of bits, a finite number of rows in the triangle. So we know what the geometry is. Again, I'm not necessarily saying that this particular geometry is the one that you want to build out of the geometries that are available at 4,096 bytes, but this is the simplest one in 4 dimensions. There's not necessarily a reason that you want the simplest one. You might want a more complex geometry because it will take more time for an opponent, for example, to decode. But theoretically, this can be read directly from hash. It doesn't really have to be decoded because it's constructed of hash. It's like, we think a lot about security in the web, but I'm actually trying to construct things that will be just visible. If we look at NFTs, for example, this is just a series of color codes in a frame, 256 by 256. Those are all hash. So we've got hashes of hashes. It's all predictable, right? If we know the parsing length, then we can XOR through the parsing length and derive whatever the hash is. But we need to know the parsing length, and we need to know the integer space. So if we know that the integer space is 6 hexadecimal numbers, then that's the maximum range. Then we can parse out that distance within the hash and decode it. But that's if somebody would want to find out what picture was stored in a hash, right? Like other kinds of information won't resolve to a color space. They will need a different schema. On the other hand, if you choose a schema that follows this, then it will be decodable. That is certain.
Thank you for confirming that I caught the gist of where you were headed with all this. I'm glad there are theoreticians like you out there so that practitioners can springboard off of your coattails.
I mean, honestly, I'm springboarding off of a very brilliant man's coattails, and this concept of the document ID in IPFS was not even his. So there's a lot of brilliant people who are building in this way or thinking in this way. And if you really want to learn more about this, I would suggest to look up Michael Zargham, and especially this paper on color-directed acyclic graphs, because I think if you think about blockchain and data sharing and data applications in blockchain, CDAGs are where it's at. Most everything in a Merkle tree is a DAG. So once we get colorization of those DAGs, then we discover the holes in our DAGs, which are considered this idea of cliques, or it's any set of functional relationships between nodes which are unique between those nodes, a clique. So it's like if you have a clique within a hexagon, it must be a triangle. This is the same sort of algorithmic mathematics space that you can use to resolve a lot of utility off of hardware, across code in blockchain.
Thank you very much. In case you'd like to discuss more and validate perhaps assumptions, I recommend to, of course, bounce these off the Swarm researchers.
Yeah, for sure.
Perhaps we would also perhaps would recommend take a look at the people in the Statebox project, because they've been working on graphs for quite a while.
Statebox, you think?
Yeah, they're a different project, but they've been working on the graph theory for a while, and they might be nice partners to.
Well, I would definitely check out what they've got up on the web. Anyway, thank you very much. I'm going to go ahead and dodge that.
Okay. Thank you, Petra. There we go. Let's continue. See, it is almost 5. Let's see, I have Alba Tomas Bell about open social network.
Hello. Hi, hello, everybody. Thank you for the opportunity to present. I'm going to share my screen. One second. Okay. I'm going to present Open Social Network. It's really simple compared to the whole explanation before. We want to build a social network where all opinions can be expressed. It will be kind of Twitter, but based on Swarm. Our team is composed by 2 members. We are Alba and Jordi. And well, we work as web developers. We are building an open social network, which is a censorship-resistant, permissionless, and decentralized social media platform, of course, based on Swarm. It will be a frontend, fully based on the backend of Swarm. It will be a non-profit. Well, it is a non-profit project, and the motivation comes after all those problems that are appearing related to the main social media platforms such as Facebook or Instagram or Twitter maybe, that are acting as censors of our time. We consider that those companies do not have should not have the power to censor any voice, and that's why we thought that building a social network based on Swarm would solve these problems. Well, I do not need to explain what is Swarm here, but we chose Swarm because it offers us a whole backend, and it's also a cheaper way to build a social network than compared to build a social network deploying contracts directly on the Ethereum network. And why you would or should join the Open Social Network? Well, one point is what I said, it's a censorship resistant network, but also it is not based on the extractive attention economy. We do not want to win money with the attention, and we want the user to be the owner of their data. So I think it's some of the main differences with the main networks. We do not share the polarization that is promoted with all the other platforms. And I wanted to share just some technical aspects that it's written in Vue framework and hosted on Swarm. It communicates with the Swarm network with BJS library APIs. We also assume that the user has access to a Swarm node. I think it's quite an important one. And well, it would run with a web browser. And now I would like to start with the demo, as I think the idea is quite easy to get. Just 1 second. I wanted this one. Okay. We get in here and we log in with our MetaMask. One second. I think I have a problem with. Now I think it's okay. So we enter and we log in with MetaMask. I will change the account because I want to create a new account. Okay. Okay, so now I am.
Perhaps you could turn off the video to save bandwidth. Sometimes you break up a little bit.
Okay, perfect. Better maybe.
Thank you.
Okay, so now we are a fully new user. We have a welcome page where you can see, well, a bit of the presentation of the network. And then we have the first step will be connecting to a vNode. We have to write the address and we can check our connection. The next step will be buying a batch of stamps for the node. And then, well, it's a bit slow, but we wait for this one. And then we create our profile. We won't store many information, and so user can keep as anonymous as he or she wants to. I am using a whole frozen scheme just to keep a funny user experience. So I will keep with Anna, and I like flowers. Okay, so I have the batch stamp. Let me store it just for a second in the, because I will need it later. 1 second. You wouldn't need to do this, but it will make it easier later. Okay. So now we start. We have to sign because we are posting the feeds. And so we come here. We can edit our profile. Here I will choose an image I have prepared. Now we can just post the image by a link. Maybe in the future we will use a drive so that you can post your images and your videos with your drive, but now we are not using it still. And we will save it. Okay. Well, I will also add an address from another user so that I can follow. No, sorry. Well, I can follow, but I will do it the other way around. Now I just want to store my account address and switch to the other user. So now I will switch to the other user. Okay. And then you will see. Perfect. Okay, once you have logged in and registered before in the social network, you will have a different message. You have a welcome back, and you just have to check the connection and buy the badge if you do not have bought it before. But now it's what I said. I will pick the badge stamp and just start here so that it does not ask me. Okay, so I go to my user. Now I am Olaf. I have my bits, and I have my wall where I can see the bits that other users have posted. I forgot to write a post from the other user, but we can see the posts of a user, another user I follow. I can also post some bits in here. Now it is really simple. We can add any text. And at the moment, it will appear MetaMask also and sign the message. Okay. That's it. We can see it in order. The most recent post, it will appear the first one. And that's it for the demo. You can see it's in development, and well, there are many things to do still, but we wanted to share anyway the presentation because it was, well, it is a nice thing to show. I come back to your presentation, and just to finish, we want to build a digital social network. Just our physical society is imperfect, but without a magnifying glass on our imperfections. Please, we are, well, the project, as we said, it's in development. We want anyone who wants to help developing, it's invited to. Anyone who wants to test the user experience, now it's not much to do, but in the future it will be more. And also anyone who wants to share the social network with the community, everything will be great. You can visit us on this GitHub link, where you can see much more about the project and how to run the example also. We have to say that for development, we used the B factory, just if you want to test. And well, we want in the future, we will also add some next steps that we want to add at the project so that other users can contribute in some concrete aspects, just to help maybe that anyone can say anything. Well, I think that's all. I don't know, any questions?
Yes, there are. Thank you. A question from LDefNB, not IDefNB. With the question, I see this has not been tested yet on mainnet. Is it running on testnet perchance?
Yes, it's in testnet, and the B node is with the B factory, and it's all in test by now. Yeah.
Thank you. And another question was, are there any ideas that we can add as contacts to test?
I'm not sure how to answer this question.
As in, could others test with you?
Well, the way to test it would be to reply all the same development environment with the B factory, and also with the clone and with MetaMask test account, so that you can repeat all the same, more or less the same as I did in the presentation.
Okay, thank you. Question from Tomasz. What else besides the censorship-resistant features of Swarm attracted you to work with Swarm?
Well, I would say also the simplicity in. We saw that it was quite accessible with all the BJS API to contribute, to use it. and we thought that it would be a good alternative.
And a question from Gregor. Can other projects use the same protocol? As in, would Facebook's, Twitters, and TikToks be interoperable?
Well, it will be fully open so that anyone can fork it in case it is interesting. The code is open, so but by now it is not interoperable with the others. Maybe in the future it would be interesting to take information from one to another. Yeah, maybe.
And aside from contributors on the GitHub, what would you be looking forward to right now for the project?
Well, any apportations would help the development. We had the Swarm grant, which has been the first stone in the way, but it would be great to have other contributors. Also, any other help that, or any other, I would say, person who shares our values and have new ideas to build a better project will be welcome. As we say, we love IDEA, but we do not own it. So anything, we invite you to make the project yours also and make it bigger, just because it can be a good project for all.
Great, thank you.
Thank you very much.
No further questions. So that's the GitHub as repository is what you got open now, right? Open social network. Yeah, so for people to find more information.
Yeah.
Then I have Tjert Alin, who is in the call. There we have Tjert.
Hi, Robert.
Hi, Tjert. You would be presenting on, I believe.
I would be talking about the project Galileo, which is about maps, OpenStreetMaps. So I will try to share the screen. Just a second.
Okay.
I guess the whole screen is okay, and then the present mode on the slides.
We can see from your background that you love maps. So
yes, I'm all about maps. And with Corona, you know, staying at home all the time, but I can just turn around and see the whole world behind me. Okay, so the Galileo project, it was actually presented already at the Swarm 1 event. It was called Fair Maps back then. I will share the link to the recording later on. So the recording shows how the UI works, and also goes through all the scripts for transforming data and things like that, although very quickly, but it might be helpful if you want more information. So the project Galileo is, I would call it, it's two things. So it's a technology proof of concept, but it's also a sort of community proof of concept. And the technology part is about Swarm and FairOS as the layer on top of it. So the maps are sourced from OpenStreetMaps. You use some scripts. You can use some scripts that are provided on the GitHub page to transform them to proper structure, and then import them into the key value store in FairOS that is using Swarm as the underlying storage. And Galileo also implemented a front end for using FairOS to display the maps. You can zoom, you can scroll through the maps. You can add markers to the maps, which are then saved to FairOS and Swarm. Then because we have this, I'll go to that a bit later. So this idea of community providing the maps, there's also this idea of a registry pod that contains links to other maps that has been used here. There's just a simple proof of concept implementation of this. So because the architecture of FairOS is such that you have these pods which are like drives on your hard disk, and they can be made public. So if you expose this pod containing, the pod can be containing files which don't have like a theoretical limit on their size. In this case, it can be used for key value store or a document store. In this case, we use the key value store. And so if you expose this, imagine you expose one of these pods to the public, and it contains links to where the actual maps are located, then this pod would be like a registry pod. And maybe now I touch upon the community proof of concept aspect of this project. So we believe that maps are something that should be maintained by the community, or could be maintained by the community. So in the OpenStreetMap case, this is the idea. So the community updates the maps. For Galileo, we imagine that there could be like country maintainers that could make sure that the map is up to date regularly and publish these maps to their pods. Such a maintainer, how would they get compensated for this? So theoretically, they should receive more traffic because they're like the originator. If they have their own node, right, they're the originator of this new data that, of course, the freshest maps. So also, so we want to build a community around this. So we have in mind some kind of a community building exercise. I will not go into more detail now because just want to maybe touch upon this, that this is something that we have in mind. But then these country maps could be aggregated sort of like in a registry pod. So for example, Fair Data Society would have a pod where you could, the registry pod that you could apply to. So for example, you would say, I would say, maybe I have a country map for Slovenia. I'm this maintainer. Could you please add me? And a user can could pick, maybe we could pick several such registry pods, or just maybe the best one on his user interface, and immediately have all the maps available. So this is something that we are experimenting with. But of course, it's maybe not even the maps that are the most valuable. It would be later on would be some kind of layers. So on top of maps that add value. So I don't know, maybe you have a list of restaurants in your country that you maintain, sort of like your own little Michelin list, and you would like to share that, and you would be the maintainer of that. Yeah, the maps, so maps are, you know, the first use case they were covering, but one could imagine many different other types of data that could be maintained and shared in this way. So ideas here always welcome. You can try out Galileo, but please note that currently we're upgrading FairOS to work with the latest version of B. So you'll have to, the instructions in the GitHub say which version is the last one that will work out of the box. So in the coming weeks, also the newest version should work. But here is the GitHub link. It includes, the GitHub repo includes the instructions on how to test a map with the local FairOS and how to create and share your own map. So we would also appreciate feedback on this process, how it works out for you. But more will be coming up actually in the coming weeks. So because we will build upon this idea at the upcoming events. So this is like maybe a heads up on this. And to contact us, you can use the email fairdatasociety@ethswarm.org, because this is a Fair Data Society project. Well, okay, this is a quote from Galileo. I thought maybe for Friday it would be appropriate, but basically I wrap up with this, Robert, and I would give the mic back to you. Thank you.
Thank you, Chert. It looks like my question would be, how are you going to ensure the quality of the map updates? You mentioned the community will be responsible, but is there any coordination?
This is actually part of the experiment. Imagine that some maps will be bad. So if you use this simple case where Fair Data Society curates this like manually, then I guess you would get complaints about the map and you would remove that provider from the map. But you could like automate the process further on with some kind of curated registries. You know, you complain, you vote, you lose tokens if you get removed from as one of the providers. So you can, this can be explored in various ways. But basically, currently, it's not. We're not giving any guarantees, right? It's but some kind of reputation-based system would have to be put in place.
Interesting. Okay, we have a question. Let's see, is there any provision for timestamping when the various pods were last updated from the OpenStreetMap's source data?
So I guess not at this stage. So if you update your data, I guess, well, since FairOS supports this updating, the new map should be available. But if you want to like advertise that there's a new map, this system is not in place per se, right?
Okay. Thank you. That concludes the questions. Thanks again. And I'd like to now give the room, at least the floor, to one of our participants who couldn't be here, but he pre-recorded his demonstration, his presentation and his demo, which is Igor Shadurin with the project Zumarok.
Hey, my name is Igor Shadurin. I'm a participant of the ethswarm grant program. The project I'm going to talk about is called Zumarok, which is a platform for viewing and publishing short videos. Once upon a time, when social networks were just starting to appear, I really enjoyed creating communities, small games and applications. Most of them were not in great demand, but some of them became quite successful. The success was manifested in hundreds of thousands of active users and subscribers. If you found a way to hack growth, then sooner or later the administrators of social networks would come and regulate the permitted ways of growth. I don't see a big problem in the regulation of social platforms, but as a result of such regulation, owners often lose their communities due to retroactive rules. This situation was repeated with me from time to time on different platforms. I started seeing similar situations more often among other content creators. They lost all their articles, photos, videos, and subscribers in one click of the finger of the social media administration. And then one day I asked myself, why not create a platform where all your content and subscribers are controlled only by you? So that no administration can simply take the results of your work. In theory, this could be solved using distributed technologies. But quite recently, a tuning point came when all the technical possibilities for this appeared. It became cheap to store user database in a distributed registry due to second-level networks. Any heavier content such as photos or videos can now be stored distributed in Swarm. Zumarok is an example of social network built on top of FairOS, Swarm and the Ethereum-compatible XDAI blockchain. Upon registration, the user receives a mnemonic phrase, which is the only way to manage user data. XDAI will store basic information about the user and his subscribers. FairOS stores all downloadable content, photos, videos, and previews. With the help of the sharing methods implemented in FairOS, you can very easily get a feed of the content of all the people you follow. It's no secret that distributed networks are not always quickly synchronized with each other. especially when it comes to big data. For this, within the framework of the Zumarok project, a caching server was implemented that allows an ordinary user to feel as comfortable as in Web 2, although in fact to operate with data in Web 3. This implementation is interesting in that it can be run on any VPS server or local machine via Docker, and the user will securely access the content of the entire network. So, if a user doesn't trust a public node, he can always switch to a private one. In addition, watching and publishing short videos is not all that the created backend is capable of on top of Swarm and XDAI. Any developer can create their own mobile or web application and connect it to the existing network. The entire user base and their content will instantly be available in the new application. Now the mobile application is available by invitation, perhaps in the most moderated app store, the Apple Store. This is done in order to immediately start building a bridge between censored store apps and decentralized data. It is necessary to learn how to match each other, and it's not so easy. But if it succeeds, the Swarm community will be able to get a huge number of new users. Thank you for the attention. For any questions, please contact me by email. Bye.
Thank you, Igor. And we're starting to see a pattern here, how projects like the Open Social Network and Zumarok come to Swarm eventually because of the limitations by the existing centralized solutions. It's nice to see. For now, we go to the last presentation by the project, and then we'll have some announcements. For the last presentation, I'd like to invite Jeremy Bott, who's working on the project Digital Life. Jeremy, are you alive at the moment?
I am alive, yes.
Okay.
I'm doing some last minute tweaks. Yeah.
Jeremy recently started experimenting with Swarm after experiments with other, let's say, decentralized storage networks. And we're very keen to hear, Jeremy, what you've been up to.
Oh. Yeah, 1 second here.
And what the Digital Life project entails.
How do I do this? Go here.
In the meantime, I'd like to announce again, just like in the previous days of the summer school, at the end of this session, you can send your Ethereum address to the host of this webinar, which is the Black Swarm logo, to receive the Swarm Summer School NFT, to be eligible for receiving the Swarm Summer School NFT at the end of the program.
Okay, is
there
this,
we go.
Working? Great.
We're seeing a screen which is being shared. There we go.
Getting a flickering here. There we go. Okay. So yeah, I'm here to talk about the Digital Life project. I think this would maybe be a little bit different than the other talks. I'm gonna mostly talk about the project itself, and very much looking forward to getting feedback and hearing potentials on what others might see in this project.
Jeremy, before
yep.
you continue, I'd like to point out that in your screen share, the overlay of Zoom is blocking part of your presentation.
Oh, okay. Deal with this. I'm just going to hide the thumbnails. Is that okay?
this is a lot better. Yeah, it should cover most.
Okay, cool. This, there you go. So yeah, I'm here to talk to you about the Digital Light project, where we scan living animals and then we share the data. There we go. So first of all, I guess a little bit of context is to give you an idea where I'm coming from. My name is Jeremy Bott, and yeah, I've been working with computers for quite a while, and specifically I enjoy moving analog into digital for quality and sharing abilities, and obviously the ability to edit, and hopefully the ability to secure and store and archive. This is me in like 1995, where we were moving. I was working at a local radio station, and we're moving from reel to reel to digital editing workstations. And this is me demoing this stuff and loving what I'm doing here. To give you a deeper picture is, I've always been interested in medical, and in particular, just anatomy and physiology. And my plan was originally to go on to be a doctor, but then my mother shared with me that Jerry, there's going to be a lot of school involved, and for me that was it was a big turnoff, because I was going to be learning from books that were published that were getting quite old, and that I realized I was going to be learning ways that other people had seen the world, as opposed to having direct access to that data myself and exploring and figuring out the world for myself. So eventually, instead, I got into just computers in general, specifically computer support. So I got a Microsoft certification, and what that Microsoft certification means that I became basically a product specialist. And when I realized that my entire career was dependent on a proprietary closed source piece of software, well, I let it expire. And then I shifted into animation. This computer graphics was a way of exploring reality visually, without barriers and without there's no predefined path necessarily. So I've worked on film and TV and video games, and then some science work as well. And currently, right now, I actually have 1 foot in the science and 1 foot in entertainment. So to kind of converge these paths now is, if we talk about recording life in general, 30,000 years ago in the Chavot caves in France, these cave paintings were put up, and it really shows you how long we've been trying to capture life and store it and archive it. And then in the late 1800s, someone was recording motion, and they were doing it in a very interesting way. And funny enough, this was actually Charles Darwin, and he was using this very interesting way of recording motion through a piece of glass, and then kind of tracing this plant as it grew to determine the paths in which these plants grew. I thought that was pretty interesting. And then right around the same time, you had Edward Muybridge, which I think most people, if you study motion at all, have seen these. This is pretty much the first time we've recorded actual motion. And this was kind of the result. So I think this was one of the first times, we had like any kind of video. This was, I think, 1877. So now let's move to 1957, and this was the first digitally recorded animal, and it was the child of basically the inventor of the first digital scanner, and this was his kid. And now here we are in 2017, and this is when I connected with the Digital Light project. And here is a tokay gecko using photogrammetry processing. So basically a series of cameras and taking a picture, and then this ended up as like 4.5 million polygons, and a pretty large texture as well. And why do we do this? Well, it's easiest explained by a mission statement, which we stick to pretty religiously. first and foremost is open access science, allowing the world to explore whatever, whoever, wherever. And education in terms of being immersive in this, having direct access is, you can see there's a very strong similarity to the science and education. I think ideally these two components would be kind of merged. And then of course conservation, and conservation is kind of a weird thing, because I think we think of conservation, we think kind of archival maybe, when we're talking about digital, but really with the digital, the goal is to bring awareness and use that to spark conservation efforts around the world. And then of course, by sharing these. So these are some examples of the animals that we've digitized and then retopologized so that we could store them in an efficient manner online, which is, we'll get into, I guess, at the end. So then how do we do this process? So yeah, first we plan. We go to the enclosure. This is at the San Diego Zoo. This is Duncan Urshik, biologist at the University of Massachusetts. And then on the right, that's actually him at the Perth Zoo in Australia. On the left, he's setting up to take a picture, scan of a polar bear. And then on the right, he's setting up to take photographs of a rhino. So the actual recording process begins, and here we are on location. You can see in the upper left, in the background, you can see the cameras on poles, and then he's taking some handheld shots simultaneously to capture, a finer detail from close up. And on the right, that's a shark that's basically pulled out of the water and put on the deck of the ship for about 45 seconds. And that hose in its mouth is actually flushing salt water through its gills so that it can still breathe. And then here's the scanning that happens in the lab. Some tested out different setups. A lot of them are pretty crazy, especially the one on the left. And then the one in the middle is what we call the beast cam rig, which is for most small subjects. That's what we use. It's what allows the high fidelity to occur. And there's a reason for that. And it's because as much as we try to get the animals to sit still, they just won't sit still. And if you have a camera handheld and you're taking, let's say, 20 photographs of an animal, then the computer won't be able to pinpoint the locations in 3D space. So by having numerous cameras simultaneously firing, it's basically like doing a laser scan from all angles, if you could picture something like that. And then of course reconstruction. Traditionally, this is how you would reconstruct something in 3D, which was by hand. You would line up these isometric views and start pulling polygons. And that kind of works for mechanical stuff, but when you get into organic stuff, you are kind of fooled by perspective. And this is a very common thing. So a lot of the animals you see, for example, in film and TV are usually captured from photographic reference. And then you can see, the distorted angles can distort the subjects and give you inaccurate results. Plus, the subjects in film and TV are usually constructed from numerous animals. So you actually have like a male and a female and a juvenile and an older rhino, for example, all merged into one. Actually, I had a friend that worked on what was Jumanji. And I asked him what kind of rhino that was in Jumanji, and he started laughing. He's like, well, I think it's an Indian rhino mixed with a southern rhino and a juvenile, basically grabbing the attributes of numerous rhinos to construct a full one. So the process that we use is as you saw in those previous pictures, you have numerous cameras set up around the subject. All those cameras fire. And then if you look through each one of those photographs, basically you say, okay, so where's the eyeball? And then you'd say, okay, now where is the front right foot? And what it does is it basically triangulates the positions. It's the easiest way to explain it. And then you triangulate point by point by point by point, and then you end up with a mesh. And unfortunately, it's usually not that simple. The typical result looks more like this sometimes. After much tweaking, then we can get something that's a little more accurate and fleshed out. Yeah, here's some more tests. And then this is one of the better tests that came out for the rhino. And this is a view from below. So when you turn those points into a mesh, and then you project the texture onto the mesh. And this is what you get is from down below, you can see where the cameras weren't able to get underneath. There's a lot of missing data. So in cases like that, we rely on other data to kind of fill in that missing data, whether it's working with the zoologists who have a camera on a stick and they'll wave it underneath the rhino and capture video in reference like that. Or in this case, there's Ohio University had a CT scan of a rhino skull, and this was really helpful to reconstruct the front of the rhino's mouth and make sure there's a lot of, make sure we maintained accuracy there. And then in other cases, we might have to do two sets. So in this case, this was a sea turtle that was stranded. It had been bitten by a tiger shark, and you can see on the right side of its shell that there's a big bite mark in it. And then of course it's missing its front right flipper. It was rescued by this Marine Center in Florida. And then while Duncan was down there, he did a scan of the turtle before they, a couple months before they released it. So that meant scanning it on the front and scanning it on the back, kind of using this tool to trim away that excess scan data. And then, you know, we had a top and a bottom, and then you just kind of flip it over and put it on top, and then rig it, which allows us to animate it, which basically then I can slip it into position. And then from there, they're merged. And then there's a lot of cleanup obviously needs to be a lot of cleanup needs to be done. And this gives you kind of an example of like some of the missing data again that happens. So then we have to, you know, reconnect with the biologists and receive that missing data. And it's kind of a fun thing too, because, you know, when you're looking at stuff, you're not really sure what you're looking at, and you know, just kind of give you a puzzle here. And one of the things that's a challenge, this is actually the underside of a rhino's neck. The lower part is the shoulders, and the upper part is, you know, leading into the jaw. And, you know, when you're looking at something like this and you're trying to patch this data into the stuff that's missing on the actual rhino, it's kind of tricky. And then of course, verification of that data. So that basically means taking our scan model and lining it up with the original photographs and seeing, you know, checking the silhouette and see where there's issues. And you can see like in between the legs, obviously there's a lot of data in there that's been added by some of the processing. So we have to fix that. And there's numerous methods we have to finding, you know, what pieces are accurate and which pieces aren't. And then of course, working with the biologist to verify the data as well. And of course, rigging it, because one of the things that we do with our project, we feel it's important to capture motion. And this is something that I think we'll be spending quite a bit of time on over the next decades, for that matter, is because capturing a static object is relatively simple, but capturing an object in motion is very tricky. So currently the way we do it is we study the animal's anatomy, and then we rebuild that anatomy using what we call a rig in 3D animation. We use this in film and TV, obviously. By studying the anatomy, then we can determine where the pivot points would be, and then we attach the geometry to those pivot points. And that hot red that you're seeing is basically saying, you know, well, it's showing me what's attached to the bone that controls the shell of the animal. And then as I pick through the bones, that heat map would change depending on what bone is picked. And this is what the agama lizard looks like. And then, yeah, then we animate it. And it's kind of funny, some of our partners actually use motion capture to capture the motion of these animals. And this is a whole new challenge as well, because you can't use a lot of standard setups that were designed for bipedal, you know, human beings. So to do mocap on lizards and snake is quite a challenge in of itself. And I recommend checking out Savas's work. It's impressive. And then another option is using machine learning. So basically using video, and the video analyzes the motion over time, and then is able to project that motion back onto the 3D model that we created, and even create a skeleton. And some of the preliminary tests that we had. And here's an example of what happens when you have to animate it by hand. So on the left-hand side of the screen is animation curves controlling you know, the Euler coordinates, the rotation of the head, for example. And of course, the most important part of this process is sharing it. So currently we use a site called Sketchfab, and Sketchfab is a commercial website. And it's a great site. It's really cool. You can view these animals in full 3D. I would actually recommend checking it out. So yeah, I'll give you can give you the URL at the end. But yeah, you're allowed to see these animals in full 3D, interact with them, rotate them around, and you can even view them in VR, which is pretty slick. One of the goals too is to make sure that these animals are accessible for as long as possible, because some of these animals are already starting to disappear, and relying on centralized storage obviously is not ideal for long term when you start talking about 20, 40, 50, 60 years. And for an example, one of my concerns is acquisitions. So I kept saying to my partners, one day Sketchfab is going to be acquired by somebody. It's just a matter of time. And coincidentally, I think about 4 weeks ago now, they were actually acquired by Epic Mega Games, the makers of the Unreal Game Engine. So now all this stuff is kind of in their ecosystem. But so far, nothing's changed. But again, there's an inevitability to that. And that's a major concern in terms of conservation and accessibility. It's worth mentioning that all the software that I use now, I've basically converted all my processes over to all open source softwares. And these are some of the softwares that we use in order to do the scanning and cleaning up of the models. So it's kind of a nice part of it too, which means that, when I teach biologists how to do some of this process, they have full access to these tools. And I think learning about biology, one of the best methods is actually to create one of these models, because you become very intimately knowledgeable of the animals when you actually have to create them from these photographs or scan data. And in the future, looking at color accuracy is going to be a big challenge. Scanning more flora, scanning more deep sea creatures, which actually I'm working on now. I'm scanning what's called snot palace, which is a very funky looking thing, which is almost impossible to scan, because it's if you basically took it out from the depths, it would just be a pile of jelly, kind of like a jellyfish. Using procedural methods for texturing so we can get more finer detail, which would mean kind of studying these fractal-like patterns in the surfaces of these animals and how it relates to the topology, and then reconstructing that through these procedural node networks. Yeah, and in some cases, maybe some things can't actually be meshed, right, or animated, in which case we would just upload the point cloud data. This is a tree stump that's at Stanley Park in Vancouver, BC, as an example, and this is actually kind of a fun one to view online, and you can download it as well if you're curious. And then one of the big challenges I have right now is I'm working on a polar bear, which fur is a whole nother topic, I guess. So what's next? Archival. I always cringe whenever I hear the statement of, we're going to put these models on the cloud. And to me, I think calling our current methods of storage the cloud is very deceitful. I always think of a cloud as decentralized, no single point of failure. You can't grab a cloud, you can't move it. It's just there and it's ever present. And finding a place in the cloud for our models, I think is quite important. And thanks to a lot of crypto technologies that are available now, I actually see that as a reality, where, to be honest, before I wasn't sure if it would ever be possible. And that's about it. And there's always a big thanks to the Blender group and community. It's an incredible tool for animation, and it's just gotten better. In the community especially is absolutely phenomenal for those of you that are interested in 3D graphics or even 2D editing. I would highly recommend checking it out. The group that I'm representing here is the Digital Life Group, which is out of University of Massachusetts. That is Duncan Ershik. Johnson's another 3D artist partner, as well as Robert, and then myself, Jeremy Abbott. And then if you want to see the 3D models and interact with them, again, right now, they're currently available on sketchfab.com/digitallifethree. And yeah, there's my contact information. There's a contact page on verbal007.com where you can ping me on Twitter and say hello. And that's it. Thanks for your time.
Thank you, Jeremy. I must say, I'm amazed by the work you do and the way we can still, even in the future, experience these animals even though we're potentially a threat to their habitat.
Yeah.
Before I go into more project, there was a question from the audience, but how many 3D models of animals that have become extinct did you collect?
Let's see. The project started probably about, I guess, about 6 years ago. I think so far we're fortunate that I don't think any of the animals have become extinct. Some of the animals have passed. So, and that's a big thing too in terms of capturing individuals, because I think we often think of a southern white rhino as a tribe of southern white rhinos, right? But the individuals, obviously, when they pass, that's something that can't be replaced as well. But the northern white rhinos, as everyone is aware of, like they've disappeared. We don't have a scan of a northern white rhino, but we do have some of the southern white rhinos. We do have scans of some, basically the 7 species of sea turtles around the world, which a lot of those are in bad shape. In some cases, maybe there's like 30,000 left on the planet. And, with a slight temperature change or who knows what could happen, right? Those things could disappear at the blink of an eye. Yeah, I would say fortunately, none of the stuff we've scanned has gone extinct yet.
Fortunately, yes. I already see a remark in the chat. This could be great if combined with the Galileo project for a metaverse of nature.
Yeah, totally. I opened that project up just during the talk to check it out. But yeah, that's something actually we think quite a bit about. This concept of NFTs, for example, it's something I'm working on in terms of a proposal for various projects actually. But using NFTs as a way of geotagging these assets, and then also connecting those assets to individuals that created them, because I think there's a science is the process, and I think putting animals online and saying yes, this is a real animal, I don't think it's good enough. We have to associate that animal with the creators, whether it's the digital artists or the scientists or our partners. Or even the funding, like where did this, what created this asset, who paid for it, who worked on the model, and I think from there, using NFTs and wallet addresses or just identifiers attached to these is a way of giving it validity, and then being able to then pop it on a map, even more amazing, and being able to fly around the world and see the different the flora and fauna across the world, and then who worked on it, who was responsible. And I think through the reputation too, and through crypto technology in general, like funding becomes a lot more possible as well. And something I've actually thought about, which I'd love to ponder more with those that are interested. But with science, I feel that there is some topics that are becoming quite touchy. And I think a lot of scientists maybe have opinions or research that they would like to share, but how does one share anonymously yet have a reputation? And I see that as something that's quite possible now, where you can actually build a reputation with an ID as opposed to having your home address available. And I think that gives voice to those that are afraid of speaking up and have important things to share.
Definitely. Yeah. Is these models, could they also be used for exploring, for instance, evolution at one point?
Yeah, absolutely. And I guess I just realized my camera was off. As you can see, I'm in a fishbowl too. Yeah, and I think that's a big thing, is like the more accessible this data is, the more we can use things like machine learning to kind of see as these animals evolve. I think that's a massive thing. I would say too, on that note, to use machine learning, obviously you would need a massive data set. So there's only a team of 3 of us currently doing the scanning. So having a goal of scanning all of life on Earth is quite a large thing. But using systems that are more scalable, that are able to connect scientists with artists, I think is a huge bonus. And then we can start to make a much larger library of these scans, and then that'll give us enough data to actually feed into machine learning to start to analyze and see how these things are evolving.
about that data set. How big is your data set right now? Just curious.
Oh gosh. Okay. So yeah, I mean, that's a really, really good question. And in terms of the animals themselves, I mean, I think we have like, let's say 60 animals scanned right now. Again, you know, considering there's like 4 of us, we're quite happy, and the quality keeps going up. But anyway, the final retopologized models. So these models have basically been, you know, we use techniques that you use in a video game to make them light so that you can animate them in real time, right? Because you can't animate something that's, you know, 6 million polygons, at least not in real time. So I would say each of these models ranges anywhere between 50 to 100 megabytes in size. So, you know, there you go, like, you know, 5 to 10 gigabytes of information for the final models that we build, right? But if, you know, a lot of this stuff comes from photographs that are, you know, 5K or whatever, larger, right? They're massive. And to, again, if science is really about the process and the source. So if you start to look at the actual source data, so for example, maybe these algorithms to do photogrammetry from the original photographs gets better, right? It's important to be able to go back to that original data and use that to make more accurate models. If you consider all of that data, you're talking, I mean, you know, obviously terabytes in size, right? I think last time I archived some of this stuff, we're about 5 or 6 terabytes of data, and that's for 50 models. Well, there's more actually. There's a ton more models that we haven't put online, but yeah, right now we're looking at about 5 terabytes of data that I usually back up. Which, again, not massive, but when you start looking at all of life on Earth, holy cow.
Yeah. And with regards to Swarm, you started recently experimenting with it a bit, what I understood. On what aspect would assistance be of help, or what are you looking for right now to be able to test it out properly?
Yeah. Let's see. So there, you know, there's numerous projects we've looked at. Obviously, you know, Arweave was one that kind of grabbed my attention. I looked at all the solutions that were out there. So Filecoin and SIA, you know, I felt like those systems were quite complex, and then plus they weren't permanent storage. So Arweave grabbed my attention because it was a way of permanently storing it. But in terms of a working model to collaborate with people around the world, that really isn't a viable option, right? Because I mean, I don't have a desire to store a bunch of data that we're just going to be used as an intermediary in the process of collaborating with other people. And then, yeah, I came across Swarm via you, and it grabbed my attention because it felt like, it seems like Swarm is more integrated. It's not just this layer that's put on top of a storage system. It's not permanent, but then that's kind of a nice part too, because we're not wastefully storing a bunch of data, again, the intermediary pieces. And then of course there's that incentive mechanism. Again, it's built in. So yeah, there's in terms of help, I would say with everything, there's a lot for me to learn. I'm just kind of still going through the process of setting up a node myself and then being able to use it. So I don't really have too much to say yet.
Okay, I'll be sure to check out our community on Discord. It's quite helpful.
Yeah.
And of course,
I joined it.
Enormous amounts of documentation which is available.
Yeah, there were a couple questions that I had in terms of how you know, the link to Ethereum and how that all works. And when I joined the Discord 2 days ago, yeah, my questions were answered immediately, so it was pretty awesome. It was exactly everything I was asking and more. So it was, I'm looking forward to diving deeper. Just have to make the time, move away from the animals for a minute, and then focus on the storage. But
great to hear. And I hope to see. Curious to see how the project evolves and how Swarm can be hopefully of assistance in maintaining the experience and of these not yet extinct, luckily, animals. Right now.
Yeah. I guess the piece that'll be next would be for me is you know, once I've got a node set up, is then I'm sure there's presentations online of others that have done it. Basically, you know, linking a website that directly references Swarm and the data that's stored there. That'll be interesting to see and see what the throughput is. The models, again, they're not massive, but they are large. You know, a 30 megabyte file is not a not something to scoff at. I mean, Google won't even let you send that as an attachment, so that says something, I guess. But so yeah, I'd be curious on performance and stuff like that as well.
Perhaps we have an option where you could find potential collaborators on this, but there's someone else who could talk more on this, which is not me. Thank you, Jeremy. But that's Angela. Let's see where Angela Fietstum. Angela, are you online?
Yes, I am.
Angela, you have an announcement to make, I believe.
I do. So I am working as a project manager with the Swarm team. And first of all, let me say that everyone had really great projects and demos. We want to keep building on that momentum. So we are going to be hosting a hackathon at the end of October, focusing on data. So more details definitely to come on all of that. But in the interim, if you guys are interested in participating, send us a message to Summer School 2021 at ethswarm.org, and those messages can be filtered over to me. And I look forward to connecting with everybody. Thanks, Robert.
Thanks, Angela. So if you've done during this week, if you've have validated some of your ideas, or if you have gotten inspiration from the speakers or already had some, and you want to test out your ideas and show them to the world, then this hackathon could be of interest. So if you have, if it sounds interesting, please feel free to mail us. We'll keep you updated. For now, that would be via Summer School 2021 at ethswarm.org. But of course, there will be its own, there will be an announcement page with more information coming soon. And with that, I would like to thank the last presenter, which was Angela, and all presenters today, all projects, for taking the time to demonstrate their use case, their products, and how they're building and why they're building on Swarm. With that, I'd like to thank also all participants who didn't present, but who were here with us during the week. And next to that, the team which has been working behind the scenes to facilitate this whole. Again, if you would like to apply for the Swarm NFT for the Summer School 2021 participation, please send your address to the Swarm host, which is the black logo of this webinar. And with that, I'd like to close off this last day and congratulate you all for graduating the Summer School of 2021. Thank you.